June 1944, Normandy, France. American tank crews advance inland after D-Day. They encounter something that stops them cold. A massive German tank, larger than anything America has built, more heavily armored, more powerful gun. An iron monster that seems invulnerable. American tank crews try to engage it. Their shells bounce off the armor. Their tactics fail. Their tanks burn. Men die. One German Tiger tank kills 10 American tanks in a single engagement. One German tank stops an entire American infantry column. One German tank becomes a legend. But then, in 1945, American soldiers finally capture an intact Tiger tank. They tow it back. They begin examining it. And what they discover shocks them completely. The engineering, the armor, the gun, the mechanical systems. Everything is years ahead of American tank technology. The Germans didn't just build a bigger tank, they built a better tank. They built something revolutionary. This is the story of the German Tiger tank. This is the story of how American soldiers captured the most feared weapon on the European battlefield. This is the story of how engineers reverse-engineered the Tiger and changed American military technology forever. Tank warfare evolved dramatically during World War II. When the war began in 1939, tanks were relatively small, lightly armored vehicles designed to support infantry attacks. Tanks of 1939 had thin armor. Tanks of 1939 had small guns. Tanks of 1939 were almost as vulnerable to anti-tank weapons as they were effective against enemy forces. But as the war progressed, military planners on both sides realized that tanks were becoming more important. Tanks could move quickly across battlefields. Tanks could support infantry. Tanks could engage other tanks. Tanks were becoming the dominant weapon system on land. Both the German military and the Allied militaries invested heavily in developing more powerful tanks. Tank armor became thicker, tank guns became larger. Tank engines became more powerful. The arms race in tank development accelerated throughout the war. The Soviet Union built tanks like the T-34, which was revolutionary for its sloped armor. The American military built tanks like the M4 Sherman, which was reliable and could be produced in large quantities. The British military built tanks like the Churchill and the Cromwell. But the German military took a different approach. German military planners decided to build fewer tanks, but to make them significantly more powerful than the tanks of other nations. German planners decided to prioritize armor protection and gunpowder over production numbers. German planners decided to build the best tank in the world, regardless of cost. This strategic decision led to the development of the German Tiger tank. The Tiger was not the most numerous tank. The Tiger was not the easiest tank to produce. But the Tiger was arguably the most formidable tank on the European battlefield. The German company Henschel was one of Germany's leading tank manufacturers. Henschel had been building tanks for the German military since the 1930s. Henschel had experience. Henschel had engineering expertise. Henschel had manufacturing capabilities. In the early 1940s, the German military issued requirements for a new heavy tank. The requirements specified that the new tank should have thick armor to protect against anti-tank weapons. The requirements specified that the new tank should have a large gun to engage enemy tanks at long range. The requirements specified that the new tank should have reliable mechanical systems. Henschel designers began working on the design. The designers started with the idea of a tank that would be much larger and more heavily armored than anything previously built. The designers wanted to create a tank that would be nearly invulnerable to existing anti-tank weapons. The result was the Tiger tank. The Tiger was enormous compared to other tanks in service in 1942. The Tiger weighed 56 tons. The Tiger carried armor up to 4 inches thick on the front. The Tiger was armed with an 88mm gun that could penetrate the armor of any enemy tank at significant distances. The Tiger engine was a Maybach V-12 diesel engine that produced 700 horsepower. The Maybach engine was one of the finest tank engines ever built. The Maybach engine provided the power to move the 56-ton tank across battlefields at reasonable speeds. The transmission and suspension systems of the Tiger were sophisticated and well-engineered. The Tiger used a torsion bar suspension that provided a smooth ride despite the tank's weight. The Tiger's transmission allowed the driver to control the tank's movement precisely. The armor of the Tiger was not just thick, the armor was angled. The German designers understood that angled armor deflected projectiles more effectively than vertical armor. The armor of the Tiger was arranged in a way that maximized the protection of the tank's crew. The gun of the Tiger was extraordinary for a tank gun in 1942. The 88mm gun had high muzzle velocity. The 88mm gun had excellent accuracy. The 88mm gun could penetrate armor at long ranges. The 88mm gun made the Tiger a lethal anti-tank weapon. When Tiger tanks first entered combat in 1942, their effectiveness shocked Allied military commanders. The Tiger's armor seemed nearly impervious to existing anti-tank weapons. The Tiger's gun seemed devastatingly effective. A single Tiger tank could engage multiple enemy tanks and emerge victorious. A single Tiger tank could hold up an entire enemy unit. A single Tiger tank became a weapon that soldiers feared. Stories began spreading among Allied soldiers about the Tiger. Tales grew with each telling. A Tiger that had fought off an entire tank battalion. A Tiger that had destroyed 20 American tanks. A Tiger that was nearly impossible to kill. Some of these stories were exaggerated, but many of them were based in truth. The Tiger was genuinely the most formidable tank on the European battlefield. A Tiger driven by an experienced commander and crew could outfight multiple American or British tanks. American tank commanders began developing tactics to deal with Tigers. The American tactics emphasized speed, numbers, and teamwork. American tanks were faster than Tigers. American tanks were more maneuverable. American tanks could be produced in larger numbers. The strategy was to overwhelm Tigers through numerical superiority and maneuverability, rather than trying to defeat a Tiger in a head-to-head tank duel. British tank commanders developed similar tactics. The British understood that they could not defeat a Tiger in direct combat. The British had to use superior numbers and clever tactics. But despite these tactics, Tigers remained formidable opponents. A good Tiger commander could position his tank to provide maximum protection while engaging enemy forces. A Tiger tank crew that worked together effectively could accomplish extraordinary things on the battlefield. The fear that Tigers inspired among Allied soldiers was part of their effectiveness. Soldiers who feared Tigers sometimes made poor tactical decisions. Soldiers who feared Tigers sometimes retreated when they might have advanced. The psychological impact of the Tiger on the battlefield was as important as the tank's technical capabilities. German military planners understood this. German military planners used Tiger tanks strategically to achieve maximum psychological and tactical impact. German military planners positioned Tigers where they could engage large numbers of enemy forces. German military planners understood that one Tiger could affect the outcome of battles far beyond the tank's ability to destroy enemy vehicles. Finding an intact Tiger tank was extremely difficult for Allied military forces. Most Tigers were destroyed in combat. Most Tigers were destroyed by Allied artillery or airstrikes. Finding a Tiger tank that had been abandoned with minimal damage was rare. But in 1945, as German military forces retreated in the face of advancing Allied armies, American troops finally discovered an intact Tiger tank. The tank had been abandoned by its German crew. The tank had been damaged, but the damage was repairable. American military commanders immediately recognized the importance of this discovery. They ordered that the Tiger tank be recovered and transported to American military facilities for detailed examination. They ordered that American engineers and tank experts examine every aspect of the Tiger's design and construction. The Tiger tank was carefully loaded onto a transport vehicle and moved to an American military base. Once it arrived, military engineers and tank specialists began the process of examining the tank in meticulous detail. They opened access panels. They studied the engine. They examined the transmission. They studied the suspension system. They examined the armor. They studied the turret mechanisms. They examined the gun. They studied the ammunition storage. They examined the crew compartment. They studied the electrical systems. They examined the mechanical systems. They studied everything. What the American engineers discovered was that the Tiger was not just a bigger tank. The Tiger was a completely different approach to tank design. The Tiger incorporated engineering principles that American tank designers had not fully considered. The Tiger demonstrated technical knowledge that was advanced for its time. When American engineers began examining the Tiger's Maybach V-12 diesel engine, they were impressed by its sophistication. The engine was powerful, 700 horsepower from a 12-cylinder diesel engine. The engine was well engineered, every component was carefully designed. Every component was precisely manufactured. Every component worked together as an integrated system. The fuel injection system of the Maybach engine was particularly impressive. The fuel injection system used mechanical injection pumps and injectors. The injectors atomized diesel fuel into fine mist that could be burned efficiently in the engine's cylinders. American engines of that era used different fuel delivery systems. American engineers studying the Maybach engine saw that the German approach to fuel injection was superior. The cooling system of the Maybach engine was sophisticated. The engine generated enormous amounts of heat that had to be dissipated. The cooling system used radiators and a water pump to circulate coolant through the engine. The cooling system was designed to maintain optimal engine temperature under combat conditions. The ignition and starting systems of the Maybach engine were reliable. The engine could be started in cold weather. The engine could be started quickly when needed. The engine's reliability meant that Tiger crews could depend on their engines functioning under combat conditions. American military engineers studied the Maybach engine and understood that this was one of the finest aircraft and tank engines that Germany had produced. The Maybach engine was a product of German engineering excellence. The Maybach engine demonstrated technical knowledge that American engineers would have to incorporate into future American tank engines. The transmission of the Tiger tank was mechanical rather than automatic. The Tiger driver had to shift gears manually. The Tiger driver had to manage the transmission carefully while driving in combat. But the Tiger's transmission was brilliantly designed. The transmission provided smooth gear changes. The transmission allowed the driver to control the tank's movement with precision. The transmission was reliable. The transmission could handle the power output of the Maybach engine without braking. The suspension system of the Tiger was revolutionary. The Tiger used torsion bar suspension. Torsion bars were long steel bars that twisted to absorb shock from the terrain. The torsion bar suspension provided a smooth ride despite the tank's 56-ton weight. American tank designers were impressed by the torsion bar suspension. American tanks of that era used other suspension designs. American tank designers understood that the German torsion bar suspension provided advantages that American tanks could not match. The track and wheel system of the Tiger was designed to distribute the tank's weight evenly across the ground. The Tiger's tracks were made of steel. The Tiger's tracks were wider than American tank tracks. Wider tracks distributed weight more effectively and reduced ground pressure. The steering system of the Tiger allowed the driver to turn the tank with precision. The steering system used a mechanical transmission that translated steering wheel input into movement of the tracks. The steering system was reliable and responsive. American military engineers studying the Tiger's mechanical systems understood that German tank designers had approached tank engineering from first principles. German designers had optimized every mechanical system for reliability and performance. German designers had created a tank that was mechanically superior to American tanks in many ways. The armor of the Tiger was the most visually impressive feature of the tank. The armor consisted of steel plates arranged to protect the crew and engine from incoming fire. The front armor of the Tiger was thick. The front armor was up to 4 inches thick. 4 inches of steel could withstand most anti-tank weapons of 1942. 4 inches of steel could stop a direct hit from a 75mm gun firing from moderate range. But the genius of Tiger armor design was in the angle of the armor plates. The armor was not vertical. The armor was angled. Angled armor caused projectiles to deflect rather than penetrate. Angled armor made the Tiger more resistant to anti-tank fire than the thickness of the armor alone would suggest. The sides and rear of the Tiger were less heavily armored than the front. The sides were about 1.5 inches thick. The rear was about 1 inch thick. This design reflected the reality that the Tiger would usually be engaged from the front while facing enemy forces. Protecting the front was more important than protecting the sides and rear. The top of the Tiger was relatively thin. The top was protected by a 0.75-inch steel plate. But tank designs of the era rarely expected engagement from above. The top armor was sufficient for protection against strafing aircraft or artillery shrapnel. The turret of the Tiger was heavily armored. The turret was the most heavily armed part of the tank. The turret housed the gun and the gunner. Protecting the turret was essential for protecting the tank's primary weapon system. The armor of the Tiger was not just thick. The armor was scientifically arranged. German designers had studied how projectiles interact with armor. German designers had understood that armor at angles was more effective than armor that was vertical. German designers had optimized the armor arrangement for maximum protection. American engineers studying the Tiger's armor arrangement understood that German designers had approached armor protection scientifically. American tank armor up to that point had been relatively simple. American tank armor was often relatively vertical. American engineers understood that they had much to learn from German armor design principles. The gun of the Tiger was an 88mm cannon. The 88mm designation referred to the diameter of the gun barrel's opening. An 88mm gun was a large gun for a tank in 1942. Large guns meant more destructive power. The 88mm gun had been originally designed as an anti-aircraft gun. The Germans had adapted the anti-aircraft gun for use in tanks. The gun provided the Tiger with firepower that was superior to contemporary enemy tanks. The gun had high muzzle velocity. High muzzle velocity meant that projectiles traveled fast and were difficult for enemy tank commanders to predict or evade. High muzzle velocity meant that projectiles could penetrate armor from greater distances. The gun had excellent accuracy. The gun's design ensured that projectiles left the barrel in a predictable manner. The gun's accuracy meant that a skilled gunner could hit targets reliably. The gun could penetrate the armor of any Allied tank of 1942. The 88mm gun could penetrate American Sherman tank armor from distances of over 1,000 yards. The 88mm gun could penetrate British tank armor. The 88mm gun made the Tiger a devastating anti-tank weapon. American military planners studying the Tiger's gun understood that the gun represented a leap forward in anti-tank firepower. American tank guns of that era were typically 75mm cannons. The American 75mm gun was adequate against most German tanks. But the American 75mm gun was significantly less powerful than the German 88mm gun. American military leaders made the decision that American tanks needed more powerful guns. This decision set off a chain of events that led to the development of more powerful American tank guns. American military designers understood that they had to upgrade American tank firepower to match German tank firepower. The effectiveness of the Tiger in combat derived from the combination of thick armor, powerful gun, and reliable mechanical systems. No single feature made the Tiger effective. It was the combination of features that made the Tiger extraordinary. A Tiger tank could engage enemy tanks from a distance at which the Tiger could hit targets reliably, but enemy tanks could not penetrate Tiger armor. This gave the Tiger an overwhelming tactical advantage. Enemy tank commanders could see a Tiger tank, but couldn't engage it effectively. The Tiger could engage enemy tanks with devastating firepower. Tiger tank crews that were well-trained and experienced used this advantage to devastating effect. Experienced Tiger crews would position their tanks to provide maximum protection while engaging maximum number of enemy forces. Experienced Tiger crews would engage enemy tanks at long range, where the Tiger's superior gun and armor provided the greatest advantages. American tank crews learned to fear Tiger tanks because of this imbalance in capabilities. An American Sherman tank would be destroyed by a Tiger at distances where the Sherman's gun could barely damage the Tiger. American tank commanders understood that engaging a Tiger in a direct duel was probably suicidal. American tank tactics changed as a result of the Tiger threat. American tanks began operating in groups rather than as individuals. American tanks used superior speed and maneuverability to outflank Tigers rather than engaging them directly. American tanks used ambush tactics and combined arms, artillery, infantry, aircraft, to deal with Tiger tanks. The psychological impact of the Tiger on Allied soldiers was profound. Soldiers who had encountered Tigers and survived knew the terror of facing a weapon that seemed nearly invulnerable. Soldiers developed a deep respect for the Tiger and for the German tank crews who operated them. When American military engineers began studying the captured Tiger tank in detail, They organized the investigation systematically. Different teams of engineers examined different aspects of the tank. One team examined the engine and fuel system. Another team examined the transmission and drive system. Another team examined the suspension and track system. Another team examined the turret mechanism and gun system. Another team examined the armor and protective systems. Another team examined the electrical and communication systems. Each team took detailed measurements. Each team made detailed notes. Each team sketched important features. Each team understood that they were studying the most advanced tank in the world, and that understanding how the Germans had built this tank would be important for American military technology. American engineers compared the Tiger to American tanks like the M4 Sherman. The comparison showed the differences clearly. The Tiger was larger. The Tiger was heavier. The Tiger was more heavily armored. The Tiger had a more powerful gun. The Tiger had a more powerful engine. But American engineers also noted that the Tiger had disadvantages compared to American tanks. The Tiger was less maneuverable. The Tiger was slower. The Tiger had a smaller ammunition capacity. The Tiger consumed more fuel. The Tiger was more mechanically complex. The Tiger was more difficult to maintain. American engineers understood that tank design involved trade-offs. The Germans had traded maneuverability, speed, and ease of maintenance for armor protection and firepower. American tank designers had made different trade-offs, prioritizing production numbers, ease of maintenance, and maneuverability over maximum armor and firepower. Both approaches had advantages and disadvantages. The German approach produced a superior tank in direct combat. The American approach produced a tank that was easier to manufacture, easier to maintain, and that could be produced in much larger numbers. American military engineers studying the Tiger's armor design learned important lessons about how armor protects tanks. The key insight was that armor angle matters. Armor that is angled deflects projectiles rather than absorbing the full force of projectile impact. American tank designers began incorporating angled armor into American tank designs. American engineers studied the measurements of the Tiger's armor plates. American engineers calculated the effective armor thickness when projectiles struck the armor at various angles. American engineers understood the mathematics of how projectiles interact with armor. This knowledge was incorporated into the design of future American tanks. The M26 Pershing tank, which appeared in 1945, had angled armor inspired by Tiger design principles. The M26 Pershing had thicker armor than the M4 Sherman. The M26 Pershing had a more powerful gun than the M4 Sherman. The M26 Pershing was influenced by what American engineers had learned studying the Tiger. Post-war American tank designs incorporated even more of what American engineers had learned studying the Tiger. The M47 Patton tank had significant armor improvements based on Tiger design principles. The M48 Patton tank continued this evolutionary process. The M60 Patton tank reflected decades of accumulated knowledge that began with studying the captured Tiger. The influence of German tank design principles on American post-war tank development cannot be overstated. American tank designers understood that German designers had developed superior approaches to armor protection. American tank designers incorporated German principles into American designs. The result was a steady evolution of American tank design that was influenced by German engineering principles. The impact of the Tiger's powerful 88mm gun on American military planning was profound. American military leaders understood that American tanks needed more powerful guns. American military leaders authorized the development of more powerful tank guns. The result was the development of the 90mm tank gun. The 90mm gun had higher muzzle velocity than the 75mm gun. The 90mm gun could penetrate armor more effectively. The 90mm gun was comparable to the German 88mm gun in firepower. The 90mm gun was incorporated into the M26 Pershing tank, which appeared in 1945. The M26 Pershing with its 90mm gun was significantly more effective against German tanks than the M4 Sherman with its 75mm gun. American gun designers studied the mechanisms of the Tiger's 88mm gun. American designers studied how the gun was mounted. American designers studied how the gun was fired. American designers incorporated what they learned into American gun designs. Post-war American tank gun development continued to be influenced by what American designers had learned studying the German 88mm gun. American tank guns evolved over the decades, but American gun designers remained influenced by German design principles that they had discovered studying the Tiger. American military engineers were particularly impressed by the Maybach V-12 engine of the Tiger. The Maybach engine was one of the finest tank engines ever built. American engine designers studied the Maybach engine in detail. American engine designers examined the fuel injection system of the Maybach engine. American designers studied how the Maybach injectors atomized diesel fuel. American designers learned from German injection system design. American engine designers examined the cooling system of the Maybach engine. American designers studied how the cooling system maintained optimal engine temperature. American designers learned from German cooling system design. American engine designers examined the construction of the Maybach engine. American designers studied how the engine was built to withstand the stresses of combat. American designers learned from German manufacturing principles. American military planners authorized the development of more powerful tank engines. American engine manufacturers built new engines influenced by what American designers had learned studying the Maybach engine. American tank engines improved over the years, partly because of what American designers had learned studying the German Tiger engine. The influence of the Maybach engine on American tank engine development was subtle but real. American tank engines evolved over the decades, but American engine designers remained influenced by German design principles that they had discovered studying the Maybach engine. The transmission of the Tiger was a mechanical transmission rather than an automatic transmission. American military engineers studied how the Tiger's transmission worked. American designers examined the gear ratios of the Tiger transmission. American designers studied how the Tiger's transmission allowed the driver to control tank movement. American designers studied the reliability of the Tiger transmission. American transmission designers were impressed by the German approach. German designers had created a transmission that was reliable, precise, and capable of handling the power output of the Maybach engine. American transmission designers incorporated what they learned into American tank transmissions. American tank transmissions improved over time, partly because of what American designers had learned studying the German Tiger transmission. The influence of the Tiger's transmission design on American tank transmission development was significant. American tank designers understood that German transmission designers had solved problems that American designers were struggling with. American designers learned from German solutions. The torsion bar suspension of the Tiger was revolutionary for tank design. The torsion bar suspension provided advantages over other suspension designs that American tanks used. American military engineers studied the Tiger's torsion bar suspension in meticulous detail. American engineers examined how torsion bars worked. American engineers studied how the suspension allowed the tank to traverse rough terrain smoothly. American designers recognized that the torsion bar suspension provided advantages for tanks. American designers began incorporating torsion bar suspension into American tank designs. The M26 Pershing used torsion bar suspension influenced by German design principles. The M47 Patton used torsion bar suspension. The M48 Patton used torsion bar suspension. The influence of German suspension design principles on American post-war tank development was significant. American tank designers understood that German designers had developed superior suspension systems. American designers incorporated German principles into American designs. Modern American tanks still use torsion bar suspension based on principles that trace back to German tank design of the 1940s. The torsion bar suspension of the M1 Abrams tank is descended from design principles that American designers learned from studying the Tiger tank. The M26 Pershing tank was the American response to the Tiger. The M26 Pershing incorporated many of the lessons that American military designers had learned studying the Tiger tank. The M26 Pershing had thicker armor than the M4 Sherman. The M26 Pershing armor was angled like the Tiger's armor. The M26 Pershing had a more powerful gun than the M4 Sherman. The M26 Pershing had a more powerful engine than the M4 Sherman. The M26 Pershing was heavier than the M4 Sherman. The M26 Pershing was comparable to the Tiger in many respects. The M26 Pershing had armor protection comparable to the Tiger. The M26 Pershing had a gun that was comparable in firepower to the Tiger's gun. The M26 Pershing had superior engine power and was faster than the Tiger. American military planners authorized the M26 Pershing based partly on lessons learned from studying the Tiger tank. The M26 Pershing appeared in 1945 and saw limited combat in the final months of the war in Europe. The M26 Pershing represented a major step forward in American tank design. The M26 Pershing demonstrated that American designers could build tanks that were comparable to German tanks in quality and capability. The M26 Pershing was influenced directly by what American designers had learned studying the captured Tiger tank. After the war, American tank designers continued to be influenced by German tank design principles that they had learned studying the Tiger. The M47 pattern was directly descended from the M26 Pershing. The M47 pattern had improvements in armor, engine power, and gun systems. Many of these improvements were influenced by German design principles. The M48 pattern was the next evolution. The M48 pattern had even better armor protection. The M48 pattern had a more powerful engine. The M48 pattern had an improved gun system. The M48 pattern was a superior tank that reflected the accumulation of knowledge that American designers had gained over decades, partly from studying German tank design. The M60 pattern continued this evolution. The M60 pattern had even more armor protection. The M60 pattern had an even more powerful gun. The M60 pattern incorporated modern technology while remaining influenced by German tank design principles. The M1 Abrams, which entered service in 1980, represented the culmination of decades of American tank development influenced by German design principles. The M1 Abrams had advanced armor protection using composite armor inspired partly by principles that American designers had learned from studying German tank design. The M1 Abrams had a powerful gun system. The M1 Abrams had advanced mechanical systems. The M1 Abrams was the world's best tank, and part of that success traced back to lessons American designers learned studying the captured Tiger tank. The Soviet Union also had access to Tiger tanks and captured German tank technology. Soviet tank designers studied German tank design principles and incorporated what they learned into Soviet tank designs. Soviet tank designers examined captured Tiger tanks and other German tank designs. Soviet designers studied German armor design. Soviet designers studied German gun design. Soviet designers studied German engine and mechanical systems. Soviet tank designers incorporated what they learned into the design of Soviet tanks. The T-34, which had been a revolutionary tank earlier in the war, was further improved based on lessons learned from studying German tanks. Soviet designers developing the post-war T-44 and T-54 tanks incorporated principles they had learned from studying German tank design. The T-54, which became one of the most widely produced tanks in the world, incorporated design principles influenced by what Soviet designers had learned studying German tanks. The influence of German tank design principles on Soviet tank development was significant. Both American and Soviet tank designers learned from German tank design. Both superpowers incorporated German design principles into their tanks. The result was that global tank design in the post-war era was influenced by German tank design principles discovered during the study of captured German tanks, like the Tiger. The influence of the Tiger tank on post-war tank development in America, the Soviet Union, and other nations was profound and lasting. Tank designers around the world studied the captured Tiger tank and other German tanks. Tank designers incorporated what they learned into tank designs. Over the decades, tank design evolved, but the fundamental principles that German designers had developed remained influential. The armor design principles that American engineers learned studying the Tiger influenced American tank armor design for decades. The gun design principles influenced American tank gun development. The engine and mechanical principles influenced American tank engine and mechanical development. The suspension design principles influenced American tank suspension development. Modern tanks around the world remain influenced by design principles that trace back to German tank design of the 1940s. The M1 Abrams, the British Chieftain and Challenger tanks, the German Leopard tanks, the French AMX tanks, the Soviet T-series tanks, and tanks from other nations all incorporate design principles influenced by German tank engineering. The captured Tiger tank provided invaluable lessons for post-war tank development. The Tiger represented the culmination of years of German tank design and engineering. American, Soviet, and other tank designers learned from the Tiger and incorporated what they learned into subsequent tank designs. The study of the captured Tiger tank had a broader impact on American military technology development beyond just tanks. American military planners recognized that German military technology in many areas was advanced or equivalent to American technology. American military planners understood that America needed to learn from German technology advances. This realization led to intensive programs to study captured German military equipment in many areas. German radar technology was studied and influenced American radar development. German jet engine technology was studied and influenced American jet engine development. German aircraft design was studied and influenced American aircraft design. German electronic equipment was studied and influenced American electronic development. The captured Tiger tank was just one example of how American military planners used captured German technology to advance American military capabilities. The systematic study of German military technology after the war contributed to American technological advantages during the Cold War. The Cold War competition between America and the Soviet Union drove rapid technological development, but American development benefited from the foundation of knowledge that American engineers had gained from studying captured German technology, including the Tiger tank. The Tiger tank was part of a broader pattern of how American military technology development was influenced by German technology.